Greg, welcome to the Circular Strategies podcast. We're delighted to have you join us today. As we get started, why don't you tell us a little bit about yourself, Triton Ties, and a bit about your journey?
Sure. Well, I really appreciate the invite. Thank you for asking me to be on the podcast. Done some great work with Tim, and he's doing excellent things out there in the circularity world. So, when I answer this question, I start back to 1974. And I've really been in this business since 1974. And people look at me and they're like, you don't look like you're 80, years old or whatever. And because my father started his own company called Riverside Recycling back in 1974. And I distinctly remember being 6 years old. And this was in February, it was the winter. And he took us down to this place on the wrong side of the flood wall on the Ohio River across from Louisville, Kentucky. And he said, "Hey, I want to show you. You got something." It was me and my brother Matt, who had previously been my partner for a long time. We got out of the car, and he said, "Happy birthday, son! I'm starting my own business." And I was looking at a really old, dilapidated scrapyard off to the left and a field to the right, and we were behind a fence. And I said something like that. I only see a field, and he goes, "Yeah, that's where I'm going to build the business," which he did. And you can, go back and look at what the inflation rates were in 1974. It was a pretty audacious decision. Little did I know at that time that I was going to spend my childhood all the way up until I was 18, as a lot of people that grow up in the scrap business did.
Absolutely.
Working down there at the recycling plant, and we were more of a traditional plant. We dealt primarily in paper. But in those days, cardboard wasn't brought in roll-off trucks by waste haulers. It was brought in by pickup trucks and guys that would travel all around and break cardboard down and stack it up really high and rope it down. And so we would have this fleet of pickup trucks coming in every day. And then we would have paper drives, and people would bring in paper in there. For years, my childhood, I'm unloading people's newspapers from trunks of their cars. But gradually, my father was a consummate entrepreneur, and he expanded the business and ended up with a plant on the other side of the river over in Louisville, Kentucky. We ran our own front loaders. We were servicing the Ford plant, starting to do mixed paper and mixed waste and cardboard and stuff like that. And so I kind of got to watch these various things happen. And unlike maybe some kids that grow up in the business, my dad wasn't a big, son, let me show you about the business. I was more cheap labor working down at the metal scales, weighing in copper and brass and aluminum and that kind of thing. And we had a metal yard, and we did a lot of aluminum cans and stuff. So, all through high school, me and my buddies were working at the plant, and every Saturday and Sunday, I got to do one sport in high school, and that was wrestling. And then I was working every weekend, and I think my brother and I started working 40 hours a week when we were probably about 14, right? So a lot of hard work, seeing my dad working 7 days a week. I liken it to some kids that grow up on a farm. Some of them can't wait to be farmers, and some of them just want to get off the farm. And that was me. I wanted to get off the farm. So I wanted to be a pilot. If you think back to at this point, it's 1986. And the big movie that came out that year was Top Gun. So I decided that I wanted to be a Navy pilot. My dad was in the Navy, and he was actually on an aircraft carrier. So I go off to Purdue University, never thinking I was ever going to come back into the recycling industry, and ended up going into the Navy ROTC program. And in that program, you also get exposed to the Marine Corps, because the Marine Corps is part of the Department of the Navy. So Marine officer candidates and Navy midshipmen are all in the same program. So I got very attracted to the Marine Corps. It kind of fit my background of sports and wrestling and things like that, leadership. And so I ended up graduating from Purdue and being commissioned as an officer in the Marine Corps. And did that for 8 years as an infantry officer in the Marine Corps from 1990 to 1998. And about 1995, December of 1994, I got married to my college sweetheart. And we ended up having 2 kids. And I noticed real quick that the Marine Corps wasn't a family man's business, right? The whole time I'm in, my dad is kind of after me to come back into the family business. And by that point, he had opened up 1 additional plant in St. Louis. So I was always very reluctant. My dad was a very big personality, and I was very reluctant to kind of come back to the business. And I said, I remember saying, you know, Dad, I wouldn't mind doing that because I kind of need to, you know, to get out of the Marine Corps if I'm going to raise a family. And, but I don't want to just, you know, create some job or whatever. The prodigal son comes back and, you know, some fake job is created. And so he said, well, you know, I've always wanted to open up a second plant in St. Louis and we would need a plant manager. So I did that and got involved as a plant manager at a plant in St. Louis that's what's called Northside Recycling. Eventually managed both plants in St. Louis. And the great thing about that first plant was it was kind of like a starter plant. We had 1 account, which was the Schnucks account. So we took grocery store bales of cardboard, brought them back, broke them open, made heavy bales and loaded rail cars. And we did that in a partnership with Willamette Paper that got bought by Weyerhaeuser, got bought by International Paper. So I was exposed to a lot of these things that kind of became formative in the way that I think now. But, you know, I mean, I was on you know, if the Bobcat guy didn't show up, I was on the Bobcat. If the forklift guy didn't show up, I was on the forklift. I ran the office. I did some light maintenance, which my guys would laugh at me now. They don't even want me to touch a wrench now, you know. But I got exposed to the business from a hands-on standpoint and from a business development standpoint. And it's kind of funny that when you don't know what to do, you do what you know. So in the Marine Corps, as soon as you start an operation, you get a map and it's laminated. Well, this is back in the day. It's probably all on you know, digital now. But you got a laminated map and you started plotting various grid coordinates of the enemy positions and your positions and friendlies and everything. So I'm kind of sitting there. You know, we have this 1 account, which is barely paying the bills, if that. And I started thinking about, okay, how do I apply what I learned in the Marine Corps? Strategy, tactics, you know, thinking like maybe the enemy thinks. And so I went out, I get a map from some map store, I laminate it, I put it on the wall, I break out the yellow pages, and I start plotting where are the haulers, where are my, you know, competitors, you know, they're in red, you know, the haulers are in green, they're potential allies, this and that. So I kind of formed this business map over the first couple of weeks, and I realized that, hey, the local business, it's a logistics game, right? If we offer the same service, they want to get that truck dumped, they want to get back on the road. So I started thinking about the business a little more tactically, a little more strategically, and of course, a lot of the leadership that you learn in the Marine Corps applies. It's some people think that Marines are like a bunch of Prussians marching around and screaming and yelling, and they think boot camp. That's really not what being a leader in the Marine Corps is like. It's a very servant type leadership. So that translated well. And so we started growing the business, started offering different services, kept expanding my family. My wife and I eventually had 4 more kids. So we have 6 adult children now, and raised them all in St. Louis, which has been a fantastic place to raise a family. And so, you know, along came about 2011, and we ended up being able to do a deal with Republic Waste. They were expanding their recycling operations, and they wanted to buy our recycling operations in St. Louis. So we sold our business in St. Louis to Republic Waste. At that time, I was the CEO of the company. We had 2 plants in Nashville that my brother oversaw. We had 2 plants in Louisville, and so we still had those, and we sold St. Louis. And so as part of that, we started doing, when we had these plants scattered around, we started doing single stream recycling. And if you look at a MRF, if you look at a single stream line, a lot of your capital expense is in separating the containers. So what we would do is we would separate the paper and the trash and the glass with our various single stream lines. We then bale the containers and centralize them in Louisville at our plant, actually in New Albany. So we had this central container line for our network of MRFs around this region, Nashville, Louisville, and St. Louis. So right about the time we sold St. Louis, we had put a new container sorting line into our New Albany plant. And it was very efficient. And we did this in a partnership with Coca-Cola because they wanted the PET.
Yeah.
Kind of our strategy was work with large companies that want our material and get them to provide the capital for our growth. So we kept our debt down, and we typically paid them back with material on a per ton or a per pound deal. And it worked really well. So we put this new line in, and it was very efficient, and our material only filled up about 65% of that capacity. So we said, well, I wonder if there's other people that have mixed bales of containers that they would like to sell us. So that was in January of 2011. By March of 2011, we were running 3 shifts, 5 days a week on that line. So tremendous need for that processing capacity. So I'm sitting here. We've been successful in St. Louis. We had this equity transaction with Republic. We're sitting on some capital. So we kind of create this new business model that we call a PERF. So instead of a material recovery facility, we had a plastic recovery facility. Okay. And that became our new business model. And we thought that we had literally just, struck the mother lode, because PET was selling in the 20s, HDPE was selling in the 30s, 30 cents a pound. Polypropylene was coming online. That was probably in the 20s. And so it was a really great business. So we decided to expand it. So we expanded into Atlanta, and we built a PERF in Atlanta. And then we expanded into Baltimore. We built a PERF in Baltimore. And then we built a facility in St. Louis that was going to take the residual from those PERFs and further process it. So this was all going very wonderfully until about 2014, 2015. So for the first 4 years, it was great. We got a little overextended, right? Money was cheap. We got this great business model. We have awesome, 24-month trailing EBITDAs. People are willing to loan us a ton of money. And then the fracking revolution hit. And a lot of people that are listening may not understand how the price of plastic is directly tied to the price of oil and natural gas. And so who would have thought, you and I growing up in the 70s, that we would become the largest producer of oil and natural gas in the world, right? Mm-hmm. I mean, you and I remember the gas lines and everything else, right? And the OPEC and the embargoes and whatnot. Right. But all of a sudden, because of fracking, well, I say all of a sudden, it kind of hit us all of a sudden, but they've been working on it for 20 years. We're the world's largest producer of oil and natural gas, which meant a cheap virgin plastic, an explosion of virgin plastic capacity, and that puts a ton of pressure on recycled plastic, and the prices just plummeted. All right.
So you lost your market.
We lost our market. We got into a business that we thought we understood, and we really didn't understand it. Now, one of the things that we inherited from my father was the relationship with Willamette, the paper mill, right? And that was our backbone, was cardboard. Okay. So I was used to the drill just being, how much can you go and collect? Because you always have a market for it. We had a floor price. We had a premium over a market indicator. So we always worked our models off of our floor, right? But you always had a home. So we could get very creative in going out and mining the waste stream. We launched a fleet of front-end loader trucks to go collect commercial single stream. We're putting 8-yard containers at businesses that had never been able to recycle before. We're running 6 front loaders around St. Louis, just pulling in massive amounts of mainly cardboard, because again, we could get creative because we had this market. Well, when this 2015 thing hit, what we realized is those same economic fundamentals don't exist in plastics. And that has been something that has stuck with me for the last 10 years, frankly, as we've really tried to address that problem. So in plastic, there are no long-term contracts. Everything is spot. Nothing is strategic, because the molder, which is the company that's taking the plastic and actually melting it down and making a part, they can always replace your material with virgin or wide spec, which is like virgin, but it's just not quite virgin. And therein lies a major problem with the plastic recycling business. So that kind of sets the background a little bit for where I was in 2015, right? Had a lot of success.
Yeah.
That was based on certain things that became very apparent to me. Overextended, had to shut all those perfs down except our St. Louis plant. Shut down New Albany perf. In the midst of all this, we had sold our Nashville business to Waste Management, and we had sold our Louisville business to Westrock. So that capital kind of funded this expansion along with some debt. We ended up shutting all that down. I think I laid 180 people off face to face.
Oh, no.
That was tough, very tough.
Mm-hmm.
And we kind of pulled back to St. Louis. You know, when you're growing, everything is great, right? It's easy to grow because the problems that you have with growing are good problems. I've got too much business. I don't have enough people. Well, it's easy to hire some more people, train them. You know, it's hard to shrink. It's really hard to shrink. It's almost like, you know, I'm a history buff. And so it's almost like, I liken to like Napoleon, like getting within view of Moscow and then the winter hit, right? And then it's just retrograding back and you leave crap out on the battlefield and some people get left behind and you're trying to bring it back. So finally we got back to St. Louis, got all that stuff shut down, and we formed almost like a fortress St. Louis, which is where our plant is now. We sat down after the smoke cleared and said, what do we need to do to be successful in this business? And we looked at who was successful in this business. And they all had one thing in common. They weren't selling the molders. They were the molder. They bought bales and they made a part. Okay. And I can go through them, and I go through them a lot, right? It can be KW making paint cans. It can be Trex making decking and all the lumber guys, Fibron, you know, AZAC. It can be Mohawk buying PET bales and making carpet. It can be ADS buying ACPE bales and making drain pipe. You know, IWT buying polypropylene and making subterranean water management systems. Okay. Those all were very successful. And thank God for them, because if it wasn't for them, there wouldn't be a plastic recycling industry in America. Okay. So we said, okay, well, we need to figure out a product, right? And that's when we hit on the railroad tie. That started back in about 2016. So that kind of takes us up to the railroad tie. I know it was a long answer and I apologize, but I kind of got to lay that background to let you know kind of how we got to the railroad tie. We were a plastic recycler in search of a market.
I think, first off, thank you very much for your service, Greg.
Oh, you're welcome. Yeah. But I do want to point out, I never served in combat. I want to make that distinction. I came in right after the Gulf War, and I got out in 1998. So the guys that fought the 20-year war, a lot of my buddies, I did not do that. And I like to make sure I make that distinction.
Still appreciate it.
Thank you.
Your story about creating your own market. What do you think it was about your lifelong kind of journey as a recycler that kind of shaped the way you thought of that, about that particular problem, how you approached the product? Because, you know, in this circular economy, a lot of people are struggling with how to design for circularity or repurposing. Yet you, as a recycler, have given that obviously some thought.
What a lot of people don't understand about plastics is that when a molder is buying plastic and he's molding a certain part, he's really buying properties. So it's totally different than paper. Okay, so in paper, or maybe even in metal, or maybe it's a ferrous metal. In paper, if I think I have the highest quality paper, let's say I think I have hard white ledger, and it goes to the hard white ledger mill and they say, you know what, it's not, there's slow burn in here, there's groundwood in it. We're gonna have to move it. Okay, well, I can take that load and I can move it over to another recycler. I said, okay, I think I have sorted office paper. No, it's not sorted office paper, it's file stock. Okay, well, it's not file stock, it's mixed paper. Bottom line is it's still paper. It's gonna be pulped up and it's gonna be turned into something. Plastic's not like that, okay? When we got into the plastic regrind business, meaning not bales, but actually making regrind that was going to have to go to a molder, Our mentality was, if we're 2%, if we have 2% contamination, we're good. If we're 98% clean, we're good, which is, when I look back on it, that's ridiculous. So that means in a load, you have 800 pounds of garbage that has to come out in a filter through an extruder, right? So, and you can't have you can't have much polypropylene with the polyethylene. You can't have anything with the PET. It isn't like it's just paper and eventually can go down to the lowest grade. So what we needed something that addressed the realities of how we collect and process post-consumer plastics. And that doesn't exist. I like to say there is no sausage in plastics. All right. Think about it. When you're butchering a cow or a pig, you've got your certain cuts, which are good and this and that, but the stuff that really doesn't have anywhere else to go, and the trimmings and whatnot, that goes into sausage. It's not like you're putting bone fragments in there. You're not putting garbage in there, but it's the mixed stuff. It's the mixed meat, right? That didn't exist in plastics. And we needed a part that was big enough, and tolerant enough to be able to handle what we call the mixed olefin grades. So there's a big family in plastic that's called olefins, and that is polyethylene, so HDPE, LDPE, and polypropylene. That's the olefin grade. So we wanted a part that matched the realities of the olefin mix in the waste stream. And that kind of led us to the railroad tie. Now, we've learned a ton in the last 10 years about what that needed to look like, but that led us to that.
Well, when you talk about that, you're also talking about the contaminants of that 800 pounds in a load or 2%. They're not plastics.
They're not,
They're
right.
labels. They're labels.
Right.
They're.
Well, there could be plastics. They could be plastics, just not the type of plastic that they want. For example,
right.
It could be PET, which is a non-melt with olefins. It melts at a higher temperature, and so that's going to get stuck in the filter like a screen, and it's going to have to be filtered out.
When you took that concept and you started building a product, when did you begin to know that it wasn't just a good idea, a necessary idea in your case, but a viable business model?
When we started talking to the railroads and we started to look at the size of the market and the problem that they had. So there's a couple things. I mean, any business solution has to start with, what problem are you trying to solve? And the feedstock is one thing. So we were trying to solve a feedstock issue. We had a certain feedstock, and we needed the proper use case to use that feedstock, which was olefins, mixed olefins. Okay. But on the other hand of that is you got to use that to solve the customer's problem. Okay. So the railroads have been dealing with this problem for a while, meaning that particularly the last 10 years, because new hardwood is not as good as old hardwood, right?
I was hoping you would tell people about the old growth forests versus new.
I mean, we pretty much, harvested the old growth. And so now we're chopping down, 80-year-old oak trees instead of 150-year-old oak trees, right? And I don't know if it's the climate or the soil or what, but they're just it's not as hard. And so when the railroads start, and particularly in the high rot zones, okay, like you put a wood tie out in the desert, it's going to be there for a long time. Okay. But if you look at that southern crescent of the U.S., all right, down from, New Jersey all the way through the Gulf and all the way through the South, with a thumb that kind of shoots up the Mississippi River Valley all the way to Iowa, that's considered an accelerated decay zone. So because of the humidity that we battle here in St. Louis and all through the South, the salt, the insect infestations, the termites, those wood ties, even with the addition of creosote, they deteriorate a lot faster than they used to, and a lot faster than what the railroads are modeling them to do, right? And you also have that problem in the Pacific Northwest because it's basically a rainforest. So you have that same issue. So in that accelerated decay zone, it's 14 million ties a year. Okay.
Say that again. 14 million ties a year.
in the accelerated decay zones of the U.S., right?
Wow.
Now, when you get down into the high and the severe decay zone, so there's like a medium, high, and severe, that's 6 million ties. And those are ties that are deteriorating anywhere between 8 and 12 years. Now, they've modeled them, the railroads have modeled them the last 25. So as you can imagine, so they have a problem, all right? So once we figured out that they had a problem, and then once we got our costs in line and we knew, okay, what's this thing going to cost? I'm going to address that in a second. And then we applied just some modeling to it and said, wow, we can save these guys hundreds of thousands of dollars a mile by switching to composites. Okay. Then we figured we have a viable business model, right? Now, there was a problem though. And the problem is that the first generation of plastic ties, even though they called them composites, were not strong enough. The standard wasn't set high enough by the industry. People started businesses to meet that standard, and when they put them out in track, they broke. So that's created a headwind for us. So when we got together around our table and said, okay, we know that the railroads have a problem. Why are they reluctant? The reason they're reluctant is because the first generation of plastic ties weren't strong enough. And the reason that they weren't strong enough is that they weren't true composites. They weren't reinforced with glass fiber. So we reinforce our ties with glass fiber, right? Now, that makes them more expensive. So the first generation of composite ties or plastic ties were trying to compete with wood on price.
Are you using recycled fiber to make that composite,
No.
or is that
virgin?
You need
virgin glass fiber because it is a highly engineered product, right? It has to bond with the plastic to make a true third material. The definition of composite is you take two dissimilar materials and you combine them to create a distinctly third material whose performance is greater than its individual components. So there's a synergistic effect.
We're always looking for an outlet for fiberglass to recycle.
Right. I know, windmill blades and, glass bullets, stuff like that. So no, it basically starts at the glass plants. It basically starts as like a marble, and then it goes from there. But
gotcha.
Our aha moment was, it doesn't matter what it costs if it doesn't work. So let's produce a product that's as strong as wood the day that wood goes in, and let's sell this on a life cycle economic standpoint. It's kind of like your deck. Composite decking is more expensive than cedar, but it's going to last 25 years or more, and you don't have to service it every year, et cetera. So over time, it's going to give you a return on your investment. That's how we sell the Triton tie. And that's how my competitors sell the tie. So we're now making a tie, what we call it the new generation of composites. It's an actual composite. And over the life cycle of that tie, which we say is going to be 50 plus years, it's going to save the railroads hundreds of thousands, if not millions of dollars per mile.
Just at a high level, how does a plastic bottle turn into a composite railroad tie, or how do you take the olefin blend and turn it into the composite tie?
We deal in what we call mixed rigid plastics. There's two types. There's large mixed rigid plastics and there's small mixed rigid plastics. So let's start with large mixed rigid plastics. So if you put a 5-gallon bucket that is cracked into your curbside recycling, all right, that's going to go to a local material recovery facility. They're going to pull that off of a pre-sort line because they don't want that bucket running through the line. That's going into a bin. That bin's going to get baled, and those bales are going to probably come to me. And we buy those all over the country, all over the U.S. and southern Canada. So we bring those loads of large mixed rigid plastics into our facility. And what we're really going after is we're going after the olefins. We're going after the HDPE, the LDPE, and the polypropylene. All right. So we take that bale, we break it up, we chop it up, we remove the ferrous metal with magnets, and we put it through a sink float tank. The wonderful thing, the great thing about plastics is olefins float and all other plastic sinks. So, for example, if you were to smash up a PET bottle and put that in water and kind of dunk it down, it would sink to the bottom because it has a density greater than water. If you were to smash up a polypropylene yogurt cup, put it in water and dunk it down, it'd bob back to the top. Okay, so one of the ways we separate olefins, which we want, from non-olefins, is we introduce it to water. So we introduce it to water, we sink the bad stuff out, we float the good stuff across the top, then it goes through all kinds of other cleaning, and eventually it gets into a regrind, which is a 3/8 inch chip, all right, or a 3/8 inch piece. We then bring that over to our tie plant, and we introduce that with some other additives like carbon black as a UV blocker. We introduce some other agents to it, and then the glass fiber, and that becomes what we call a composite mix. And then we put that in the molds, like a cavity mold, and then it sits in that mold for a certain period of time until it cures, and we pull it, and we open up the mold, and it's the tie. Then we send it through quality control where we x-ray every tie to make sure that there's no voids in it and that the glass is properly dispersed. And then we texture it on the sides, and then it has to cool. And then we always test certain ties from that batch to make sure that they're up to our standard, and then we package them and we sell them. So that's kind of a roundabout way of how it happens.
Couple questions for you. Does that have a shrink? So does it shrink as it cools?
A little bit, but not much.
Not much.
Yeah.
Huh?
I mean, but the only issue is that when it comes out of the mold, sometimes it does what we call crowns. It's got a slight crown on it. When that cools, that'll settle down into a flat.
Gotcha.
Yeah.
What has been the biggest engineering and manufacturing challenge you've had to overcome with that kind of process? It looks like you've made a lot of innovation to make it happen.
We've worked very hard, Bob, to make sure that we could use the various olefins that are in the waste stream. So a lot of people that make this product, what they make the mistake of doing is they settle on a very narrow band of plastics that works perfectly for them. All right. And they say, okay, this is what we want because it works really well. Okay. And so they start their process, and then they get some orders. Maybe they go from making 20,000 ties a year to having to make 50,000 or 100,000. Well, then all of a sudden that really great narrow band of plastic that works for them, they can't get it anymore. Okay. So now they have to try a different type of plastic. We've worked very hard to say, no, we want to be able to use HDPE, LDPE, and have a tolerance for polypropylene. And that has taken a lot of trial and error. It's taken a lot of different types of additives that we use that helps this plastic play well together. It's taken a lot of experimentation with different types of glass. So the glass has a certain sizing on it. So when it's made as a filament, a chemical mix is blown on it, and that causes that glass to bond with certain types of plastic. So there's glass that's made for polycarbonate plastic, glass that's made for nylon, glass that's made for polyethylene, polypropylene. We've experimented with different types of glass, different types of formulas for the one that works best for us. Always keeping in mind that we have to be able to scale this business. The narrower we make our band of plastics that we want, the harder it's going to be to scale. So that's probably the biggest engineering innovation that we've had to do.
Does that mean you have multiple recipes, or does it mean you have a wide tolerance for what you can utilize?
We have minimums and maximums of the different types of plastic that we can use. Yeah, but it's not super tight. You know what I'm saying? So we know we have to have this much HDPE. We know that we only want this much LDPE, and we know we only want a certain amount of polypropylene. Now, if the entire tie was HDPE, that would be fine. But we use the other materials also to broaden the scope. And I mean, there's other things
And
that
to
we've done.
consume,
Yeah. There's
you
other things that
consume,
we've done that I don't really, there's a lot of proprietary stuff that we've done.
absolutely.
It is a highly engineered product. And that's, we have a tagline that says engineered for the long haul. And we can't make the mistake of just, putting whatever plastics in there and hoping that it works. This is a highly engineered product. Yeah.
As a highly engineered product, are there other advantages that come with the plastic ties and the composite ties, I'm sorry, that Triton Ties makes over and above the economic aspects and the environmental aspects of wood and concrete that you might see in your product or that the customer might experience from your product?
Well, I mean, it doesn't rot, obviously. I mean, that is
Right.
that's the number one reason that it works. So it's as strong as oak, and it doesn't rot. Um,
Hmm.
Otherwise, it can be, the other thing that's kind of neat about it is it can be handled with the exact same equipment that they use to
Right.
install wood ties. It can be interspersed with wood ties. So you, like
Uh-huh.
with concrete, you have to put in all concrete. So if you want to replace 5 miles of track and you want to use concrete, you need to do all 5 miles with concrete. You can't go 5 wood ties, 5 concrete ties. No, it's a whole system. With our tie and with any composite tie, they can be replaced one for one with wood, and that's how they replace the majority of their ties. So what the railroads do, believe it or not, is they actually walk the track with spray paint. All right, and they look at the ties that look like they can't make it for the next cycle, and they spray paint them, and those come out. Now that might be every fifth tie, and they pull those out. They put a new tie in, so our tie can go right in there with those wood ties. And so it really is conducive to how the railroads maintain the what they call the way, the maintenance of way.
Wow. I'm curious, are they all one color or does different railroads want different colors
Yeah.
or
Well, I don't know what they want, but our ties are like the old Model T Ford. You can have any color you want as long as it's black. You know.
there you go.
Now,
It could it probably
but you know what? That is a great point about recycled plastic.
right.
When you mix it all together, it's not colorable unless it's black.
Uh-uh.
Okay,
Right.
so when we talk about what's the problem with plastic recycling, well, everybody wants FDA, Food and Drug Administration approved plastic that's colorable because they have equity in their brand color. Tide,
Hmm.
Procter and Gamble wants Tide orange. Well, when you mix all this stuff together, you get some funky greenish gray thing that can't be colored Tide orange. It can be colored black, or it can be that weird greenish gray color. So,
Hmm.
so no, I mean the black, it's black, and the black also acts as a UV block in the tie.
Got it.
Yeah.
Yeah. Um, how do you see your product uh, playing a role in the circular economy? How do you convey that value
Yeah.
proposition?
Well, I've always been one who realizes that if something doesn't deliver economic value, I mean, hard bottom line economic value, it's not truly sustainable because it's not going to survive the scrutiny of a downturn. It's not going to survive the knife of the CFO that comes in and wants to cut costs. Okay. It's got to make economic sense. And when I was growing our recycling business at the Murph level, I said, if I can't save you money, then throw it away. We have a wonderful landfill network in this country. Okay. A lot of the world doesn't, but we do. So I need to find use cases that make economic sense, hard economic sense. Okay. And I think that's part of sustainability. That's part of being circular. But I have always argued, in fact, I just posted on Earth Day yesterday a pretty long LinkedIn post saying that trying to take a plastic package and turning it back into that same plastic package most of the time doesn't make sense. It's it's very expensive. It's technically incredibly difficult, and it often results in a package that is not as good as one made from virgin plastic. So instead of chasing a perfect circle, I look at circularity as being kind of oblong. All right. It's still circular, but it's not a perfect circle. So if I take that post-consumer packaging and I make a railroad tie out of it, and at the end of its life in 50 years or whatever, that tie needs to be pulled out, we'll take it back. We'll grind it up and we'll put it back into a tie at a certain percentage. Okay. ADS that's making drain pipe can do the same thing. Their drain pipe sits in the ground for 100 years, but when it's cracked, if it cracks, they can pull it out and make another product out of it, right? So I don't like the term downcycling. I say it's real cycling. It's real recycling, right? Because like I said, if it wasn't for the companies making durable goods, we wouldn't have a plastic recycling business in this country, as underdeveloped as it is. So I think durable goods are incredibly important for circularity, and I think we need to stop chasing a perfect circle.
It's interesting. You kind of alluded to the dual mandate of circularity, right? Where there's both an economic return, which is sustainable, and the environmental impact. And certainly your product is kind of contributing to that. But as we discuss that, what do you see the biggest gaps and opportunities that exist in plastic waste recovery and reuse? Is it is a further consideration of the fact of that oblong circle that might that is real recycling, or do you have other thoughts around the gaps and opportunities?
Again, chasing that perfect circle, trying to go, consumer facing product A back to consumer facing product A is very difficult. And we spend a lot of time and energy and resources on doing that, instead of what I call harnessing the genius of plastics to replace inferior legacy materials. So let's find out where hardwood is being used and it rots a lot and has to be replaced. Let's use post-consumer plastics to replace that, right? Let's replace, wood, clay, steel. Let's find that these infrastructure projects where we could replace concrete potentially with certain post-consumer plastics. Now, there are certain post-consumer plastics that can go back into that container, but those are few and far in between. All right. So if you look at what's successful, most carpet nowadays is PET. For years, the vast majority of PET went into fiber. It went into making that carpet. Well, that's a great use of plastic. Now, that's not circular because once that carpet's done, it's done, okay, as opposed to our product. But I think we miss a lot by chasing that perfect circle. I also think that there's a huge gap in contracts. The economic foundation, the economic fundamentals to grow plastic recycling, unfortunately, do not exist. And the brands don't quite get this. So when the brands can't get enough plastic to fulfill their goals, they blame the recycling industry. Well, there's not enough supply. I say, okay, you're right, there's not enough supply. But have you ever wondered why there's not enough supply? There's not enough supply because no one will sign long-term contracts. And our material can be replaced with virgin at the drop of a hat. As soon as the price gap gets small enough, recycles out, virgin is in. Now, how do you build a business off of that? How do you go to the bank and say, I need $20 million to build a wonderful post-consumer plastic recycling facility? What's the first thing the bank's going to say? Let's see your 24 months or 36-month trailing earnings. Well, it looks like, ups and downs and ups and downs. And well, the markets went away here and then we had a really good year here, and they don't loan on that, right? So again, my experience in the paper business was these companies, these paper mills were willing to sign 20, 25-year contracts, right? That would support the capital investment necessary to go out and creatively mine the waste stream. Unfortunately, that doesn't exist in plastics. So when the brands say, I can't get enough plastic to meet my goals, the question I ask is, How many contracts have you signed? Right? How many are you guaranteeing a home with a floor price? And the answer is no, because they have their cake and eat it too. They want sustainability, but they don't want it over time. Now, because they're fighting a quarterly battle, and you can't look at sustainability on a quarterly level. You got to look at it over time. I'll guarantee if they committed to recycled plastic over time, it's going to win economically, but they have to win every quarter. And that's just how our publicly traded companies work. So that's a huge problem with recycling. It's contracts and collaboration. If you truly want to be sustainable, I say you've got to get the recycler, the molder, the brand or the end user, the logistics person, the sustainability rep. They all got to get around the same table. And they have to say, okay, we want to use more recycled plastic. How do we do that? So Danone may not be able to make a white yogurt cup out of post-consumer plastic, but I'll guarantee all the pallets that they use, all of the crates that they use, that could all be post-consumer polypropylene that came from that polypropylene cup. We just have to view it differently. We can't view it as a perfect circle.
One of the gaps you mentioned was to, use it for other replacement, what rots or, it's not just rotting, it's stuff that's not durable to reuse, like crates and things like that. And I think it's interesting that you alluded to pallets. Are you considering at Triton Tires any other industrial uses for your concepts today? And I don't want you to speak out of school.
A vision that I call a world of ships on recycled plastic. So that's, railroad ties, that's pallets, that's, potentially, shipping container flooring and stuff like that. We have a very close relationship with a local pallet manufacturer that we supply a lot of their material. So I would say that we're not vertically integrated, but maybe we're almost virtually integrated. So pallets are a really good home for mixed olefins, right? And there's a huge opportunity there. So if you pull behind a Walmart, you will see a lot of blue pallets, stacks of blue pallets. Those are pooling pallets, and those are made out of heavy pine, okay? And they splinter, and they eventually rot, and they got to be repaired, okay? If those were made out of a really heavy-duty plastic, maybe even reinforced with glass fiber, they would be virtually indestructible. And that would suck up an incredible amount of recycled plastic. And over the long haul, it would be more economic. Okay. So again, I think pallets is a great use. I think pallets is a great use. Marine decking. How many times have we all been on the coast and we've seen wooden piers dilapidating and falling into the water? Well, now a lot of those are being converted to actual fully 100% plastic, not like decking, which has wood flour in it, but 100% plastic with glass fiber. Again, I cannot overemphasize the importance of glass fiber as of composites as a reinforcing agent. It's a whole different product. So there's just a lot of opportunities for that. I think another gap is returnables. Like you said, we are in a make and throw away. But if we were to get into a returnable economy, then you could have a heavy duty plastic crate that eventually went back to whatever factory it was being packed in, and then it would be logistically in a circle. That would save a lot of resources and use a lot of plastic.
I'm curious, the wood tie, the wood pallet, the plastic composite tie, the plastic composite pallet, is there a weight advantage to plastic?
There is a weight advantage to some plastic, but if you're going to compete on durability with wood, there's typically not So there's a weight advantage with plastic packaging via glass or metal sometimes. But if you're going to compete with wood, you're basically the same weight. Once you introduce that glass fiber to make it incredibly strong, you're basically the same weight. So we're 200 to 230 pounds, depending on our model of our tie, which is about the weight of a wood tie once it's soaked in creosote.
I have an interesting idea we'll talk about offline because of that. If you could fast forward 10 years, what do you hope this company and your impact looks like?
I mean, in 10 years, I think that the composite tie market is going to be a 3 to 4 million tie market. I think that a lot of those 6 million ties in the severe and high decay zones are going to end up being composite. And I would like to think that we would have discovered some other uses that the expertise of making the wood ties can go into. So in 10 years, it'd be wonderful if we had a 2 million tie a year business with multiple plants around the country, long-term contracts with the Class 1 railroads that guaranteed a home for plastic. And I would love, if the volume got that big, I would love to set up a network of recyclers around the country that were Triton certified. We knew the product that they made. We had a quality control software tied in, right? And what I would like to do is provide them long-term contracts with a guaranteed home with a floor price that they could go to the bank and say, I have this contract, and it flows all the way through the system. Again, going back to
The future.
That's the future,
Yeah.
right? And so then
Yeah, you went back.
we would,
Yeah.
right. And so we would solve a lot of this problem, right? Because virgin is never going to be cheap enough to put in a railroad tie. There's too much plastic in there for the part. So, and we're committed to always using recycled plastic. So I would like to, in my dream, I'm 57. So by the time I'm 70, I would love for that to have changed the way plastic recycling is done in the United States.
I've appreciated our conversation. I have one last question for you. If you could redesign how society thinks about plastic from the ground up, what would you change?
I'm going to compare this to Mother Nature, and the two things are related. Wood is an incredible product, right? Mother Nature engineered an end-of-life solution for wood, which means eventually that tree falls down, it turns back into soil, and it grows new trees. It's completely circular, right? The problem with plastic from the very beginning is it's an incredible material. If you were to hand a detergent bottle with a cap on it to an American colonist 250 years ago, that would have been, or even further back to a caveman, they would have passed that on from generation to generation because it's so incredible. It's a genius material, but we didn't engineer it with an end-of-life solution. That's the problem we're dealing with now. So it's not about eliminating plastic waste. It's about engineering plastic waste into our future. We have to think about it as recycling the genius of plastics. We just have to find the right use case to do that. So I would say start with the end of life solution in mind, and then start designing your product.
Brilliant question. Couldn't thank you enough for being on the Circular Strategies podcast. Thank you so much, Greg.
I really enjoyed it, Bob.